Alright, we're going to look at the Gizmo for sound beats. And again, this is something that's kind of optional for you to do. It's if you get done with your ringtone project and you're wanting more to do, this is one of those options. And so I'm going to kind of walk you through how to do the Gizmo. Most of you have done Gizmos before, and so you kind of know how they work. But I'm going to kind of go over some of the questions and try to help gear you towards your answer. Anytime before you start a Gizmo, you always do the prior knowledge questions, and so you'll have these two questions right here. It will want you to answer. Your first question is wanting to know, what do you notice right here? You got the ripples of two different things, and then you should see right here they're kind of interfering, and so use this to help you answer these questions. As far as answering the questions, you can either type it out on document and send to us, or if you print out the packet and you want to handwrite your answers, that's fine too. Just take screenshots and then email those to your science teacher as well. Once you do your prior knowledge questions, then you can move on into the warm-up. The warm-up always kind of explains to you how to set it up and get you familiar with it before you actually get started on it. So what we're going to do right here, it tells us you want to go underneath visual. So I've got the screen pulled up right here of what the actual Gizmo itself looks like, and you'll find in the top right this little thing that says visual. You'll want to click turn on sound A, so I'll click this right here, make sure it's checked, and then I'm going to play. And I don't want to click this play because that's going to play both these sounds together. Instead, I'm going to go right over here where sound A is, and I'm going to click play right here. And then, after I do that, I'm going to go back over here, I'm going to uncheck sound A, and I'm going to check sound B. And now I'm going to go down here where sound B is, and I'm going to click play. And so what you should be able to hear is that they're very similar. And it may take you a couple times of playing each one. Go back and play sound A again. Go back and play sound B again. But you know, after you do that a couple times, you should start to hear that they do sound very similar. Number 2, click the play icon under the word auditory. So then I'll go here where auditory is, and I'll click the play, and it's going to play sound A and sound B together. And so what you should hear is that the sound is much louder than what it is when it's just played by itself. And this leads us into activity A, which deals with constructive interference. What constructive interference is where the crest of one wave and the trough of one wave will overlap the crest and trough of another wave. So in other words, it's going to create a larger amplitude, which is going to make for a louder sound. If you've been working in the book this week, you'll know that, or maybe you worked last week in the book, but you'll know that amplitude is the distance from the central location. And so if you look on your worksheet packet, you'll see that there's a central line right here when you're drawing sound waves. Amplitude is going to be the distance from that central line to the crest of a wave, or to the tip of a wave. And so the larger that distance is, then that's going to create a much louder sound. The smaller that distance is, it's going to create a much softer sound. And so again, just kind of going over some key words. We've dealt with constructive interference and then destructive interference. We've dealt with all this in 8th grade, and we've gone over it once before already. So this should be kind of a review for 8th graders, but 7th graders we have not talked about this, and so this will be new material. But whenever you're looking at a sound wave, so this is an image of a sound wave right here. You'll see that you've got the crest, which is the highest point of a wave, and then you've got the trough, which would be the lowest point of a wave. And then the distance, like I said, between the central location and the top of a wave is going to be considered the amplitude. When you're looking at a wave in terms of wavelength would be the distance from the peak of this wave to the peak of this wave. When you're looking at a vibration, how you know what a vibration is if you'll start right here on the central location of the line. You go up for the crest, you go down the trough, and then back to the central location. That is one complete vibration right there. And so that's how you count the number of vibrations if you're having to count by looking at a picture of sound waves or so forth. All right, as we get into the gizmo, it wants to, the question for this activity is, how do two waves with the same frequencies interact? So both these waves have the same frequency. You'll see right here 440 and 440. So that means they're both vibrating 440 times per second. And so that's what the frequency is going to refer to. And the unit of measurement for frequency is hertz. And that's what the capital H and the lowercase z represents, is hertz. So that's vibrations per second. All right, so if we look, sound A and B currently have the same frequency. So how do you think sound B's sine wave will compare to sound A's? And when they mean by sine wave right here, it's just this picture right here of a sound wave. That's what they're referring to. So if they have the same frequency, how do you think their waves are going to look? And so if I've got, let me turn off sound B, and I want to go ahead and turn on sound A. So if sound A looks like this, what do you think sound B is going to look like? If it's got the same frequency, then it should look very similar. So there's sound A. If I turn on sound B, you'll see it's right over sound A. So they have the exact same sound waves. When we're observing number 2, I want you to turn the visual for sound A and sound B. So I go back underneath visual, I find where it says sound A plus B, and I click it. What happens to the two waves when they're combined? Well, you'll see this teal color, remember, is the color for sound B. The purple color is your sound wave for A. And the one that represents sound A and B combined is going to be this lighter green color. So you can look to see what's happening when those waves are combined, sound A and sound B. You make a little statement here of what you see. And then 3, we're going to make up a rule. It says in the warm-up you discovered that when sound A and B are played together, the volume of the combined sound increases. So make a rule that explains the relationship between a sound wave's amplitude and its volume. Remember, volume is referring to loudness. Amplitude and loudness go together. Anytime the amplitude is increased, it's going to increase the volume of a sound, or it's going to make it louder. Anytime the amplitude is decreased, then it's going to create a softer sound. So it's going to be, a lower volume. So use that information, write you a rule right here. So for example, when the sound wave's amplitude increases, the volume blank. And you fill in that right there. All right, for 4, we're going to draw conclusions. So it says turn on the time marker. So right here is time marker. I'm going to go ahead and I'm going to turn it on. Position the marker over a wave crest. Remember, the word crest refers to the peak of a wave. So I'm going to take this time marker and I'm just going to drag it right here. Here's a crest. There's a crest. And so I'm going to drag it right there. What is the amplitude for sound A? I go back to the gizmo screen, and right here where it says sound A at the bottom, you'll write this right here. And then what is it for sound B? You'll write this. And then what is the amplitude of it combined? Well, then you just add these two numbers together, and you should get what's right here for sound A and B. So it says, complete the sentence, the amplitude of sound A and B is equal to the sum of blank. You fill in that blank. Again, activity A referring to constructive interference. And again, constructive interference is when the when the crest and trough of one wave will overlap the crest and trough of another wave. Creates a much louder sound. All right, if we're moving on to activity B, We're going to go back, make sure everything's set up the way it's supposed to be. It says turn off the visual for sound A and B, so I'm going to uncheck this. Set the frequency of sound A to 441. Check that sound B is set to 440. So now I've got these two sounds. I've got different frequencies. So it's sound A, it's got a frequency of 441. Sound B's got a frequency of 440. So what that means is sound A should have a slightly higher pitch than sound B. Because remember, frequency is going to refer to pitch. The higher the frequency is, the higher the pitch is. The lower the frequency is, the lower the pitch is. And so use that to kind of help you guide yourselves with some of your answers. All right, so the question for this activity, it wants to know how do sound waves interact when their frequencies are different. So we're looking at destructive interference. So we're going to compare, we're going to play sound A, and then we're going to play sound B. And then we're going to look to see if we can hear a difference between the two, and if so, we're going to describe it. So I'm going to play sound A. And then I'm going to play sound B. And you may have to do this a few times in order to really tell a difference, if there is a difference. So make sure you play those and then write you a sentence right here to describe what you hear in terms of the difference in sounds there. Number two, we're going to observe. So we're going to turn the visual for both sound A and sound B. So make sure sound A and sound B is turned on. Move the time slider. So here we go, right here. Move it back and forth. So we're moving it back and forth. And we're going to describe what we see. So you may have to do that a couple times. And then describe what you see in terms of whether the waves are overlapping or they're not, so forth. Moving on to number three, we're going to move the time slider all the way to the left. So I've already moved it all the way back. Let me go ahead and move this time marker all the way back as well. For each of the times listed in the table below, use the time marker to record the amplitudes of sound A and B. And then you're going to find the sum of the two, and you're going to put that in the last column. And so it says, excuse me, make sure you pay attention to your negative sign. Some of these may have negative numbers, so you want to pay attention to that because that will obviously make a difference in your sum of the two combined. All right, so the first one is 0.0006. So I'm going to take my time marker and I'm going to drag it. And if you're looking for how do I know when I'm at that time? Right underneath where you see time marker box, you'll see a T with the seconds. You want to make sure that time matches what you're supposed to have in the box. So I'm going to drag this until I get to 0.6. So there it is. And I've got sound A, sound B. So I'm going to go ahead for sound A's amplitude. I'm going to put that in the box. Sound B's amplitude, I'm going to put that in the box. And then if I add those together, whatever you get is what should go in this box. You will do that for 0.3 and 0.4995 as well. After you get done, you can go back and check yourself by clicking this sound A plus B, and it will give you what the amplitude should be. But don't do that before. Go ahead and do that basic math and figure it out for yourself, and then go back and use that to help check it. Number four, I want you to make a prediction. Again, predictions, there's no right or wrong answers. So don't worry about that. But you want to use the data that you collected, and you're going to predict what you think sound A and sound B will sound like when they are played together. So make a prediction there. So if you've got sound A, sound B, you add those together in terms of amplitude. You should notice, again, with amplitude, the higher that number is, then the louder the sound is. The lower that number is, the lower the sound is. Use that information to help you answer the question. And then on number five, we're going to observe. We're going to click play to listen to the combined sounds and then describe what we hear. So we'll click this button right here underneath auditory, and that will play both of them combined. So you're going to describe what you hear and then write your answer there. And again, you may have to listen to it a couple times in order to get a good description. Number 6, we're going to explain why the volume of the sound changes over time. So if I'm looking at it, I want to know why it changes over time. And if you play it again, you should have seen that there are some areas where you've got some constructive interference happening, which is where the amplitude of the two combined waves is higher than or larger than the amplitude of each individual wave. But then you also have some areas of destructive interference, and that's where it's going to be smaller. It's where the crest of one and the trough of another wave are overlapping, and it's going to create a lower amplitude, which will create a softer sound. Number 7, it wants us to look at the beats and determine how many beats we hear. And so when it's changing from a soft sound to a loud sound, that's called a beat. And so let's go back, move our slider all the way to the start. Let's move this time marker out of the way as well. We're going to click play. And every time we hear it go from soft to loud, or maybe even from loud to soft, then we're going to count. And the first time through, we're just going to listen, and then the second time through, I'm going to help you count how many you hear. And this one's a little difficult, so I am going to help you with the answer. But let's pay attention real quick. Alright, and so we'll go through again. We're going to click play, and we're going to count, or I'm going to count for you how many times we hear it going from soft to loud, or either loud to soft. Alright, 1, 2, 3, 4. So I heard 4 different times, so that means that there's 4 beats within this. Alright, we're going to determine whether for number 8, whether it's constructive or destructive interference. So it wants us to turn the visual on for sound A and B. I've already got that on. And then it wants us to take our marker and we're going to move it to these times and we're going to look at it. So first one, it wants me to put my marker at 0.005. So there's my marker. Sound A is 0.9603. Sound B is 0.9511. I put those together and I get 1.9114. So this number is larger than both of these, and therefore you're going to see that it creates a larger amplitude, meaning that's going to be a constructive interference. If I go to .5, so if I go 0.51, sound A has got a negative 0.5358. Sound B has got a 0.5878. And so when those are added together, remember when you're adding positives and negatives, if they're opposite signs, you're going to subtract and keep the sign of the larger number. And so if I look here for my combined amplitude, you'll see that this is a smaller number than this, and therefore that should be destructive interference. And so use that to help you answer these last 2 on that one. Number 8, we'll make connections. So we're going to click the zoom out control. So right over here, you have a plus and a negative. So if we're zooming out, we're going to click the negative. We're going to click it 3 times. 1, 2, 3. And so this is what you should see. Alright, so when I'm looking at it, what do I see? Remember, the green represents sound A and sound B. The blue is going to represent your sound B, and then that pink color you see is going to represent sound A. So look at this. Again, you can move the time slider back and forth to see the different things. So I've got 1, 2, 3. So you should see different things here, and so you're going to write what you notice. For B, how do you think this relates to the number of beats you counted? Well, look at your green areas and see how many total green areas you have, and see if that matches the number of beats that you have. And then C, click play. So we're going to play the combined sounds, and we're going to see how it relates to the graph's green wave. And so you may have to play that a couple times in order for you to draw a connection right there. Alright, on last activity, we're going to look at frequencies and beats and how those relate. And so we want to make sure we get it set up correctly. Again, up in the top of each activity, it tells you how to set it up. So we're going to go to make the visual for sound A and B is on. So visual for sound A and B is on. Make sure the frequency of sound A is 441, and it is. And the frequency of sound B is 440, and it is. How do the number of beats relate to the frequencies of the two sound waves? So we're going to make a prediction. Again, there is no right or wrong answer. So look at your information here and come up with some type of answer that answers if you think you'll hear more beats or fewer beats if you increase the frequency between sounds A and B. And then the purpose of this activity, what we're going to do is we're going to look at how if we increase the frequency, what happens to the number of beats. Alright, so we're going to collect some data. And so on this, we want to make sure sound A and sound B is turned off. So sound A and sound B is turned off. Now, if I'm looking at this frequency difference, so what I'm going to do is take the frequency for sound A and subtract it, or take the frequency for sound A and sound B and subtract it. So 441 minus 440 is a difference of 1 hertz. Again, hertz represents the number of vibrations per second or number of beats per second. Alright, so if I'm looking at 1 vibration per second or 1 beat per second, if it's looking at it for a total of 4 seconds, how many beats will I have? Well, if 1 times 4 is going to give you 4, you should have 4 beats per second right here. And then if I'm looking for how many beats are in a second, well, again, like I said, frequency is number of vibrations or number of beats per second. So you would have 1 right there. And so you're going to go through this whole table and you're going to fill out that information. And again, you look here, for A, you have 442. B, you have 440. When I subtract those, that's a difference of 2, so that means it's 2 hertz. Well, 2 times 4 is going to give me 8, so that should be 8 beats in 4 seconds, because I'm having 2 beats every second. And then again, for number of beats in 1 second would be 2. And so that's how you fill out that table. As far as calculating, we kind of discussed that just now for number 3 with how to figure this out right here. You just divide them. So 4, you had 4 beats in 4 seconds. 4 divided by 4 would be 1. And so that's how you would get that. Alright, number 2, analyze what relationship do you see between the frequency difference and the number of beats in 1 second. So you should see that the number, or you're going to look at this column, and you're going to look at this column, and you're going to write you a statement right there of what you see. And then we're going to apply what we've got. So we've learned that you take these two, you subtract them, that gives you frequency difference. And we looked at how that causes the beats to vary per second or per every 4 seconds, so forth. So if I've got one sound with a 444 hertz frequency, and I've got another sound with 436 hertz frequency, I would take those two and subtract them. That gives me my difference, and then use that information to help you figure out how many beats per second you would hear with these two sounds are combined. I hope that helps you work through the Gizmo and answers any questions you may have. If you still have some questions referring to the Gizmo, feel free to email your science teacher through Canvas, and we will get those answers to you as quickly as possible. Have a good day. Thanks.